Example number 2 wants us to do a little bit more of the same. We're going to find the solution to negative 27 plus 6y is equal to 3 times the quantity y minus 3. Now when we start to do multi-step, sometimes it's easier. It doesn't matter what I do. If I do the inverse operation all the time, I'll eventually get the right answer. But sometimes I could do things in a certain order that saves me a step or two. Remember that our goal is for me to get y by itself on one side of the equal sign and all the other stuff on the other side. I have a problem though. I have a y here and a y here. Alright, so I think for my benefit, I think I'm just going to push that 3 through to give me 3y minus 9. And then I have negative 27 plus 6y here. Now what I'd like to do is get all the y's on one side. I want a positive y value, so I'm going to move the smaller of the two y's. Now this is 3y. I need to move the 3 with the y. If I left the 3, I can separate the 3. I could divide by 3 and get that y by itself. But with multiplication and division, I have to multiply or divide every single term. I don't want to do that yet. Remember, when we solve an equation, we're going in order of operations, but we're going backwards, right? Please excuse my dear Aunt Sally, usually works backwards when you're solving an equation, right? Usually, the first thing you do is add and subtract. The last thing you would do is multiply and divide. Does that make sense? So what I'm going to do is I want to move this whole term, and technically I'm adding 3y to negative 9 on that side of the equal sign, correct? So I'm going to subtract 3y from both sides. Now I can only subtract 3y from the y's because they're like terms. This negative 27 doesn't get touched. But here, if I have 6 y's and I take 3 away, I'm left with 3 y's. Well, I'm almost there with regards to getting y by itself. But now what I'd like to do is move this 27 over. Since I'm subtracting it from the 3y term, what I'm going to do then is add it to both sides. And when I do that, these cancel or go to 0, and I get 3y is equal to 18. 3 times y, but now is a good time to divide. In fact, this is always the last step, it seems like. And I get y is equal to 6. Well, I'm a pretty smart guy. I've solved an equation or two in my time, but I want to make sure it's the correct answer. So what I can do is take the 6 and plug it into the original equation. The original equation was negative 27 plus 6 times y. I'm going to leave the y out for a second. Is equal to 3 times the quantity y minus 3. And we said that y was equal to 6, right? That's what we just solved for. So I'm going to plug in a 6 wherever the y was supposed to go. So now I've got negative 27 plus 6 times 6, which is 36. If I push this through the... Actually, I don't need to push it through the parentheses. What is 6 minus 3? 3. What's 3 times 3? 9. What's 36 minus 27?
9.
Is that true?
Yes.
Yes. Well, bam with the bacon sizzle, this is the correct answer. Alright.
Oh, I got it. Okay. This is some pre. I didn't even know you can do that.
So both,
This is like some 7th grade.
Yes, you have a question?
Okay, so on both sides, like both sides have to be the same number.
Yeah, so hey, that's a great question. The question was, hey, and I'm going to rephrase it a little bit, because I think what you're curious about is, all right, I solve the equation, I get the answer, I plug it back into the original equation. The left-hand side should always equal the right-hand side, right? Yes. If it doesn't, then you made a mistake and you have the wrong answer, right? Okay.